everyone, welcome back. In this particular video, we will be discussing the problem linked insert. In this problem, you will have to implement some functions to insert a node at the beginning and at the end of a linked list. So there will be two functions, as you can see on the right hand side also. Those two functions will be what we have to implement. That is insert at beginning, insert at end, insert in the starting of a linked list, insert at the ending of a linked list. Note that input and output will be handled by main method behind the scenes. We do not have to change it. We do not have to implement the main method or any input output. It means we do not have to take care about input and output. We only and only have to implement these two functions. You have to implement, as clearly mentioned, insert at end, insert at beginning functions using the arguments, that is the input provided, that this what is the data which should be inserted, and return the answer based on the return type if there will be. So actually, as you can see on the right hand side, return type is void. It means we do not have to return anything, but that will be clear from the input and output format. So what is input format? Input format is there will be some queries. Q queries will be there. And for each query, what is the type of query? Query 1, 3 means that we have to insert. First query means insert at the beginning and with value 3. Insert a node with value 3 in the beginning. Second query means insert at the end, but with what value? With value 6, that is data is 6. So insert 6 at the end. Second query means insert at end. First query means insert at beginning with value data 3. So there will be some insert queries only, insert at end or beginning, depending on queries 1 or 2. And the output format, as you can see, is after each query, print the linked list where each node is printed separated by space. Although we do not have to print anything in this function because printing will also be handled in the main function. It was mentioned input output is already handled, IO is already handled. So we do not have to print anything. Only and only we have to ensure how to insert at the start or end respectively. Queries will in total be 20. It means maximum nodes which are going to be inserted in the linked list will be 20 only. So how actually we can solve it? Given that you already have a head node and a tail node. So linked list is you have to implement only, that is you will have to maintain these two pointers, which is the head pointer and the tail pointer, depending on whether we are inserting at head or at tail. So let's just do what? Let's just make initially the head pointer as well as the tail pointer set to what? Set to null, because initially when there will be 0 nodes in the linked list, so both head and tail will be null, because right now there is no nodes in the linked list. It means both are null. So currently the size is 0 and we will be given some queries. Insert at beginning. Let's first do a try run for them. So let's say we are inserting at beginning with a value, maybe let's say with a value 50. I'm inserting in the beginning a node with value 50. In order to insert any node with any value, what is the first job which we have to do? We have to create a node. So let's just create a node with value 50. Then only you can insert the node with value 50. But what we have to do, we have to insert it in the beginning. So let me just make it in the right hand side, actually in the left hand side. How can I insert it in the beginning? It should be the part of linked list. If there will be only one node in the linked list, because currently there is no node, null. If it will be the only node in the linked list, after the insertion of 50, how will the insertion look like? How will the linked list look like? Can I say that after the insertion, the linked list will only have one node with the starting node as well as the ending node as 50? Yes, surely. After 50 getting inserted, 50 will actually become the head node as well as the tail node. Why? Because it is the only node in the linked list. So it is the first as well as the last node of the linked list. That is the head as well as tail of the linked list. And obviously the next of 50 will be null. Next of 50 will be null. After 50, there is no new node or next node. So this is a kind of corner case actually. What is a corner case? If the head is null, if we can say the head is null, there is nothing to be inserted. And if head is null, there is nothing to be inserted in the linked list, or actually we can say linked list is empty. This is the first node which is going to be inserted. We can just say simply make the new node become head. That is, this 50 will become head as well as null. So this is a corner case. Let me just write, this is a simple corner case. Obviously, we will write the instruction manual in the Crio website itself. But what will happen in the insertions later on? After the first insertion, how will I do second insertion? So let's say we are inserting 40 now at the beginning only. For now, we are going to discuss for insert at beginning with value what? With value 40. So already linked list is containing one node with value 50, which is nothing but the head node as well as the tail node. So let me make 2 pointers, head as well as tail, and the new node which is about to be inserted in the front. That's why I'm making it in the left hand side is 40. So first create the node with data 40, and then how we have to insert it. After 40 is being inserted, how will the linked list look like? First node will become 40 because it is the insertion at head, insertion at beginning. And then next node will be 50, next node will be null. Because after these two nodes, there will be two nodes and the order will be 40, 50 because 40 is inserted in the front. So if this will be the order, what will be the head node after insertion? Head node will be the 40 node. What will be the tail node after insertion? Tail node will still remain 50 because we are inserting in the front now. And now tail is not changing. Last node is still remaining 50 only. Only head is changing. So how actually I am inserting this particular node? In this case, corner case, we were making head as well as a tail, both becoming the new node. Let's say new node is temp. But in this case, only and only head is going to become temp. But actually, before making the head become temp, if before updating the head and making it go to the temporary node, this temporary new node, we have to link the nodes also. And in order to link the nodes, what we have to do? We have to actually make the 40 nodes next node become 50. 40 dot next will be 50. That is temporary's node, the new nodes next should become the current head node. So first thing which we have to do is we have to make the temporary nodes next node, the new nodes next node become the head node, the current head node, which is 50, and then make the head node get updated to 40. That is temporary node, temp. So two steps after the first insertion. First insertion was a corner case because it was the first node itself of the linked list. But after the first insertion, every insertion will be following these two steps. Let's just confirm these two steps by adding one more node with value 30. So what we are doing is insert at beginning with value what? With value 30. So we already have two nodes in the linked list with the data 40, with the data 50. 40's dot next will be 50, 50's dot next will be null. Obviously not data, but the address. Let's say this is 1000, let's say this is 2000. 1000 dot next will be 2000. But for now, let's assume data is equal to address. So this is the head node of the linked list. This is the tail node of the linked list. And what we are inserting is we are inserting 30. In order to insert any node, first create a new node. So create a new node with, let's say, variable pointer temp. And in order to insert it, after this new node is getting inserted, how will the linked list look like? 30 inserted at head, then 40, then 50. So how to make the linked list look like this? Obviously, head will update because head will now be 30, the first node of the linked list. Will tail update? No, tail will remain same. So how we are going to update head? Obviously, head should jump to the temporary node. But before making the head jump to the temporary node, we have to link the nodes by making what? First step will be by making temporary dot next is equals to head. So temp dot next should become head node. So these two steps will be required. Obviously, some languages dot operator is not there. There will be arrow operator, but we can easily like get the syntax or get the knowledge at least that temporary's next node will become head. If there is arrow operator, you can use arrow. If there is any other operator, you can use that specific operator also. You can use functions also. But the syntax will or the logic will remain same. Only the code will change. So let's just actually write the instruction manual first for the insert at beginning. Then we will also write the instruction manual for insert at end. So for insert at beginning, first corner case, or actually before handling the corner case, let's make a new node. So make a new node temp with the data as parameter in constructor. So with data inserted, So make a new node temp with data inserted. Once we have made a new node, new list node actually, because the node is part of a linked list, we have to now check, is it the corner case? Is it the first node getting inserted? So if the first node is inserted, what will be the head or tail at that point? Head will be null. So if head is null, it means this is the first node getting inserted. And in that case, both head and tail should be set as the new node. So set head and tail as the new temp node, temporary node. But if it is not the corner case, then we have to do something else. If it is corner case, we can just simply return. Return means do not run the code below it. But if it is not the corner case, we have to first link the node, that is set the temporaries next node as what? Next node as the head node, the current head node, as we have already discussed. Temporaries.next will be head and make the head go to temp. That is set, the second step will be set the head as temporary itself. Order should not be changed. We should first link the nodes and then update the head node. And no need to do any other changes. So that is all. Tail should not be updated in this case. Only in corner case, tail will be updated. So this was insert at the beginning. But now let's discuss how we can actually insert at the end, the tail of the linked list. So for that, let's just start from empty linked list again. So now we are actually inserting at tail, let's say with values 10. I am inserting at end of the linked list with value 10. And right now we are again starting from empty linked list, so that every corner case is also handled. We are able to write the pseudocode or the instruction manual for corner cases also. So initially both head as well as tail will be null. We are going to insert the first node. So first create that node. This time I am writing it on the right hand side. Why? Because it will be inserted in the right hand side only, tail node, that is end node. So after inserting it, how will the linked list look like? Obviously there will be only one node in the linked list with the next pointer null. And since there will be only one node in the linked list, after the insertion, it will become both the head pointer as well as the tail pointer. It means the corner case for the insert at beginning or the insert at end is same, which means if head is null or tail is null, this means the first node is getting inserted. And if first node is being inserted, just make that first node become both the head as well as tail. That's it. No other change. So let's just first copy these three things, which is the corner case and making the node is same. But if it is not the first node, then the changes will be there. Then we have to insert in the end. So for now, we are inserting a second node with, let's say, value insert at end with, let's say, value 20. So we are inserting a value 20. There is a node data 10, which is being both the head pointer right now as well as the tail pointer right now. And we are going to insert a node with value 20. So let's just first point, create that node, and this name of the new node, let's say it is temp. How I am going to insert it? After insertion, how will the linked list look like? It will be 10, 10's next as 20, 20 is next as null. So as you can clearly see, after 20 being inserted in the last, can I say it will become the last node of the linked list after insertion? It means it will become the tail node of the linked list. Yes, surely. Will head change? No, head will remain 10. Head will remain as it is. But surely tail will change. In this case, the corner case was head is equals to tail is equals to the new node, temp node. But in the case which is not the corner case, which is the second insertion or third insertion or whatever, after the first insertion, tail will get updated too. This is not temp. This is actually tail. This is not temp. Tail will jump to the temporary node. Tail will jump to the temporary node. So tail is equal to temp, surely. But before doing this is the second step. We have to again link the node. We have to join them. But this time it is not temp dot next is equal to tail. It should be tail dot next is equal to temp. Why? 10's next should become 20. 10's next should become 20. So first step should be the current last node of the linked list. The last node of the linked list's next node will be the temporary node, not the head.next, but tail.next. Last node of linked list, next node will be temporary node. What will happen for the third insertion? Let's just confirm our 2 lines of code for third insertion to get a better understanding. So insert at the end of the linked list with value 30. So right now, assume there are 2 nodes already in the linked list, 10 and 20. 10's next will be 20, 20's next will be null. So this is the head node of the linked list because it is the first node. This is the tail node of the linked list. Tail means the last node, and a new node being inserted is value 30. So first create a new node with any name. Let's say the name is temporary node, temp node. How to insert it? First step should be chaining. How to chain? Since it should be inserted in the last. After 10, after 20, 30 should be the node. So 20.next should be 30. It means tail.next should be temp. That's why tail.next is equals to temp. It means we are doing the chaining. So tail.next is equal to temp. So we have chained the linked list. inserted the new node, but tail should also be updated. So second step should be the tail will now become the temporary node. Or you can also say tail will become tail.next. That is also correct because right now tail.next is temp only. So tail will become the temporary node. So either you can write tail is equal to temp, or you can also write tail is nothing going to be tail's next node, tail.next. Both are correct. So this is the insertion at the end. So what is the case? First, make the chaining. That is, set the tail's next node as what? As the temporary node, as a new node. And then make the tail or the update the tail as what? Tail's next node. Or you get the temporary node again. So both the functions are now done. The next part of this problem where we will actually write the code. So first of all, in both the functions, we have to make a new node which is about to be inserted. How to make a new node in Java? I will be using Java for now. So we can say list node temporary. I am going to name it as temporary. List node temporary is equal to new list node. New means we are creating a new node with new memory allocation. And inside the parameters, inside the parenthesis, I will pass the data. That is, what is the new node's data? Initially, it should be 0, but I will directly set it with whatever data which we are providing. Once the node is created, this should be the same thing for the second function. We will check for the corner case. That is, whether the node which is about to be inserted, is it the first node of the linked list as we have discussed in the approach video? Same here. That is, if head is null, it means right now there is no node in the linked list. And if there is no node in the linked list, we have to insert the first node of the linked list. Same here. If we are inserting the first node itself of the linked list, what should we do? We should actually make the new node become both the head as well as tail, because first node will be the head as well as tail. So head is equals to tail is equals to the temporary node. You can write it in 2 lines. That is, head is equals to temp, tail is equals to temp. Or you can just write it in 1 line, head is equals to tail is equals to temp, and return. Return means do not execute the remaining code because it is a corner case. Same here. For the first node, whether it is inserted as a head node, whether it is inserted as a tail node, it is just the same. It is the first node only, head as well as tail will both be the same node. So let's just do what? Let's just run the code and see. Without the corner case, obviously, we should be able to at least insert one node of the linked list. At least first query should be correct. That this first insertion should be correct. So first query having the data 2 getting inserted, and it is getting inserted properly. Then moving forward, obviously the nodes are not inserted properly, but let's just do what? Let's just write the code, remaining code. So if we are inserting the second node or third node or whatever, that is apart from first node, we are inserting n is equals to 2 or 3 or 4. At the beginning, what should we do? We should first do the chaining. How to do the chaining? Temporary's next node should be head. Temp dot next should be head. And once the chaining is done, we can also update the head itself. Because the new node is inserted at the head node, head will also get updated as the new node. Head is equal to temp. These are the 2 steps. But these 2 steps will slightly change if we are inserting at tail, which means if we are inserting at tail, the tail's next will be temp because the new node will be at the end, it will be at the tail. So current tail's next will be the new node. So tail dot next will be temp and make the tail go to the next node. Why? Because new node will be the new tail node. It is the last node now. So tail is equal to tail dot next. Set the tail as tail's next. Or you can also say tail is equals to temp because temp is the same as tail dot next. So now let's just run the code to see if all the cases are actually working or not. And if they will work perfectly fine, then we will also submit it and we will discuss the time and space complexity. Yes, all the test cases are working, even for the corner cases as we have discussed, that is for the first insertion itself. But what is the time and the space complexity? See, creating a node is constant amount of time. Creating node just means create a constructor or call a constructor and create object, constant amount of time. Checking whether a head is null, constant operation. Setting the pointers, constant operation. Then again setting the basically the next function, or you can say setting the next pointer, and updating the head is constant. So this entire function is constant. It means single insertion of a node in a linked list at beginning will be constant. Same goes for single insertion at the end of a singly linked list, given the head and tail pointers will also be constant because all of these operations are constant in nature. There is no loop required, there is no recursion required. So both of these functions are constant for single insertion, given that we have head and tail. You might have learned about linked list where there is no tail pointer, but given that we have a tail pointer, both the insertions will be constant in nature. If there was no tail, then a follow problem can be what will the time complexity in that case? That is, if there is no tail pointer provided, will the time complexity of insert at beginning change? Will the time complexity of insert at end change? If yes, then what will be the new time complexity? If not, then why not? And also, what about space? Since we are creating nodes, but it is a part of output. It is part of what question is expecting us to do. We can't say that we are taking any extra space because we are just using two pointers, head and tail pointer. So linked list is being created. That is what the output is. Whatever is a part of space complexity is nothing but extra space apart from input, apart from output. What is extra space? Nothing, just two pointers, generally 4 bytes or 8 bytes. So constant space for both the function and constant time for single insertion. For n insertions, it will be linear. Single insertion, constant. That is the time and space complexity. And there will be surely some follow-ups attached to the same problem, linked list insert. It might be that you have to insert at a corresponding index of the linked list. That might be a follow-up. Or there might be a doubly linked list instead of a singly linked list. That might also be a follow-up. So just go through all the follow-ups, try to solve them also.